ring-shaped mare lit billions of miles from the sun, out beyond Neptune in the Kuiper Belt.
They're just the tip of the iceberg. There are probably many, many more dwarf worlds that are out there waiting to be discovered.
The sixth dwarf planet, Sirius, lives in the inner solar system. It orbits around 260 million miles from Earth in the asteroid belt.
The asteroid belt is a region of the solar system between Mars and Jupiter, and this is where most of the asteroids are. This is rubble left over from the formation of the solar system.
In the early years of the solar system, small rocks collided with one another, stuck together, and built the rocky inner planets. Dwarf planets grew in the same way.
Ceres was actually starting to get pretty big. It was on its way to becoming a planet before it stopped growing, and that makes it stand head and shoulders above everything else there.
So why is Ceres called a dwarf planet, not a planet? To be a planet, it must tick off 3 cosmic boxes.
First, it needs to be a sphere. Second, it needs to orbit the sun and not another body. Third, it needs to clear its orbital area of orbital debris.
Ceres ticks off just 2 of the boxes. It's a sphere, but a small one. Only 600 miles across. That's the size of Texas. It orbits the sun, but it hasn't cleared its path of debris. It's surrounded by asteroids, so it misses out on being a planet.
Even though we call these objects dwarf planets, small and dwarf does not equal insignificant.
But being small does have its problems. When the molten core of a young dwarf planet cools, so does the heat engine that drives geologic activity.
Ceres, we thought, would basically be a big dead rock. It's a small body. It should have cooled off long ago. Nothing very interesting is going on. And when we actually got out to Ceres, nothing could have been further from the truth.
March 2015, NASA's Dawn probe arrives at Ceres.
As the Dawn spacecraft pulled up to Ceres, we saw the craters and the surface that we expected to see. And then all of a sudden, something totally mysterious rotated into view. One of the craters had 2 bright spots, almost like 2 eyes staring right back at us.
It was such a puzzle to the science community because what are these doing here? Are they ice? It looks very fresh. What on earth could it be?
Scientists find over 100 of these mysterious white spots. The largest is in a 50-mile wide crater called Akator. They are unexpectedly made up of a substance we find on Earth, sodium carbonate, a kind of salt.
We believe the salts on Ceres are actually very young. We think they're as young as 4 million years old, and that's basically like yesterday in terms of geology.
So for this episode, we're going to hunt for leather.
It's happening not on sort of a geologic era. It's happening now, today.
What could cause patches of salt on a world long presumed dead? Planetary geologist Janie Radebaugh believes a clue might be found at Mono Lake in California.
All right, I'm here looking at this beautiful lake off in the distance and standing on massive white deposits. These white deposits used to be a part of this lake at one point. The lake had dissolved a lot of the materials in it, and then as it receded, it left behind the materials as it evaporated away. And these things are, salts. They're kind of granular in texture, and just to make sure, we taste it, and yeah, sure enough, it's salty.
The salt at Lake Mono crystallizes as the water evaporates, the only way it can form. The researchers believe the same process is taking place on Sirius. This means there must be liquid water beneath the surface. But how? Out in the deep freeze of the asteroid belt.
These bright spots are located in the centers of craters. They're located around cracks in the surface. And that is telling us that this material is coming from under the surface and welling up onto it.
Absolutely nobody expected there to be liquid water beneath the surface of Ceres. We cannot explain what is keeping that water warm. On some moons, gravitational tugging keeps the interiors warm. But Ceres is not really near anything else that's very large. So the amazing thing is that we may not even understand how rocky planets work. There may be another source of energy, another mechanism for heating the interior that we haven't even discovered yet.
To find out how Ceres has liquid water, we must rewind the clock 4.6 billion years. Debris left over from the formation of the sun slams together to form the dwarf planets. As they take shape, the heavier rocky material sinks to the center and forms a hot, molten core. Slushy water ice floats.
And we're also going to do Healer.
For a while, it stays liquid. But once the core cools,
So we'll do 2 missions each
forms the solid matter.
episode.
That surface should still be solid now, so the salt patches remain a perplexing mystery.
We still haven't answered the question, how could there actually still be liquid water on Ceres? That's still a hard question to answer. One way this could happen is if it's not actually pure water, if you've mixed it with something else.
Some scientists have proposed that a salty ocean lies beneath the surface. The high concentration of salt lowers the freezing point of the water, keeping it liquid. When asteroid impacts fracture the crust, this salty water oozes up from below. The liquid swiftly evaporates, and the salt remains, leaving a brilliant white spot on the surface.
In fact, I'm willing to bet there could be water coming up now, bringing salts up to the surface, evaporating away into space, and that means liquid water is very close to the surface of Ceres right now.
Ceres has an even more startling card up its sleeve. Recent research suggests that it's an immigrant. It didn't form anywhere near the asteroid belt. Ceres may have been born alongside hundreds of other dwarf planets, many billions of miles away from the sun. So how did it get here?
We're nearly there.
Most of the dwarf planets we
Gotta take care of these soldiers or they'll just keep following us.
beyond the orbit of Neptune. But Ceres orbits between Mars and Jupiter in the asteroid belt. Its location isn't the only hint. Ceres may be an interloper. Normally, celestial objects are made of the same materials as the other bodies in their neighborhoods. But that's not the case with Ceres. The asteroid belt is mostly made up of dry rocky bodies, composed of the same heavy elements that form the rocky inner planets. Ceres is very different.
Ceres is essentially an icy world, right? It's made out of ices instead of rocks. And so that's kind of weird considering where it is.
The ice on Ceres also contains chemical compounds that in the early years of the solar system didn't exist in the asteroid belt.
The more we learned about Ceres, the more mysterious it became. One of the things is that Ceres has quite a lot of ammonia on it. And we don't find ammonia anywhere near the inner part of the solar system.
But we do find it on Pluto, its moon, Charon. and out in the frozen Kuiper Belt where we find the other dwarf planets.
We think that the origin of that ammonia would have had to be in a very cold part of the solar system, colder than where we find Ceres today.
But how an icy dwarf planet with ammonia came to inhabit a place where ammonia can't form is a huge puzzle.
This suggests to us that Ceres perhaps formed in the outer solar system and then migrated inwards to its present location in the asteroid belt.
We used to think that planetary orbits were completely immutable, that they were simply ran like clockwork and they didn't move around. Now we know that that's not the case. In the early stages of planet formation, planets move around through the gaseous disk that encircles the young sun, much like rafts that are pushed around by ocean currents.
Oh, I'm back. I had to use my restroom.
Dwarf planets wafted around on the cosmic ocean.
Ceres is sort of a smoking gun, that solar systems are much more dynamic, much more dramatic than we know. There's mounting evidence that Ceres formed farther out in the solar system, and something brought this little world in. What could possibly have done that?
The answer is the planet Jupiter. After it formed, the giant planet migrated in towards the sun. Its massive gravity disrupted the orbits of other bodies in the solar system, including that of Ceres.
The solar system formed out of a disk of gas and dust. And as Jupiter formed, it would have been plowing through this material. And if it plows through that material, it's experiencing drag. As it was losing energy, it would start...
And there's our loot at the bottom of this lake that we're going to grab too. So I'll earn us extra XP while we do this mission.
Solar system. It was dislodged from the Kuiper Belt. And yet,
So first we're going to grab the extra 3 treasure chests.
and when Jupiter stopped migrating, so did Ceres. It settled into a new stable orbit in the asteroid belt.
Once you realize that something that strange and dramatic can happen, that a dwarf planet can form far out in the solar system and be brought in, it makes you wonder how many times that happened before. Could there have been other generations of dwarf
Got a nice
planets that
bow
got
there.
towards the sun? Or maybe were thrown out of the solar system entirely.
Scientists believe that squadrons of rocks and icy dwarf planets
Too bad we can't use that, because that would have been nice to have.
solar system.
If there was a population of small dwarf planets in the outer solar system that migrated inwards, Ceres might be the sole survivor, the only one left.
So if Ceres settled into
And with that, we got the 3 chests, and that brings us to almost a level 3.
worlds,
So probably by the end of this mission, we will be level 3.
The outer solar system is interesting. But why should it be important to you? And incredibly, the answer might be inside your own body right now. For the longest time, we've wondered, where did the majority of Earth's water come from? When you think about where the Earth is, how close it is to the sun, there shouldn't have been any water here.
Understanding the evolution of Ceres, from where it formed to where we find it today, could also lead us to understand how the Earth can end up with more water than we would otherwise expect.
when the Earth formed, it was too hot for water to exist on the surface. Perhaps those squadrons of dwarf planets broke up on their journey, showering Earth with water-rich lumps of rock.
Amazingly, when we study the chemistry of water, the best match is that the water in your body right now came from asteroids themselves. Asteroids and dwarf planets that rained down and hit the Earth over billions of years.
Dwarf planets may have brought something else. February 2017, scientists announced the discovery of organic materials on the surface of Ceres.
On Earth, life uses water and organic chemistry, carbon-based molecules. The intriguing thing about the dwarf planets is that they have both of those. Pluto and Ceres have organic molecules. There's liquid water below the surface. There's a source of energy that warms the interior. It is not at all impossible that somewhere under these cold, icy surfaces, there could be life.
Could other dwarf planets host life too? Sedna and Makemake both have red-colored patches from something called tholins, organic molecules that could be a precursor to life.
Based on all the interesting chemistry they're doing, these dwarf planets could be like the test tubes of the solar system.
If there are small bodies strewn all about the solar system that had liquid water or ice, it could possibly serve as an incubator for life, just holding on to it, ready to crash into another body and seed it.
The habitable zone now extends to the entire solar system. It really expands, it greatly expands the stage for the play of life in the entire galaxy.
Perhaps we have dwarf planets to thank for our very existence.
All of a sudden, the smallest bodies in our solar system have become some of the most interesting things we've ever seen.
The idea of migrating dwarf planets opens up some intriguing scenarios, including one really out there possibility. Some of that water and organic material may not be from our solar system.
This way, by traveling the longest way, we can try to stretch out the video a little bit and you can get to see some scenery.
The more we learn about dwarf planets, the more they surprise us.
For you guys.
But there's one dwarf planet whose very existence is mystery. It's called Sedna, and no one is quite sure why it's in our solar system.
Sedna may have my vote for the single most peculiar object in the entire solar system. Here we have a world which is about 1,000 miles wide, but it is way far out in the solar system, way past Neptune.
Sedna is the most distant object we have identified in our solar system.
Standing on the surface of Sedna, looking back at the solar system, the sun would look like a really bright star, but not much more than a really bright star.
Just like Pluto, Sedna has a strange elliptical orbit. The difference is, Sedna travels from 7 billion to 93 billion miles from the sun. And, unlike Pluto, its orbit can't be explained by its close proximity to Neptune.
The weird thing about Sedna is its orbit. How could it have gotten that elliptical when it's that far away from any of the major planets? If you have an object that's close enough to Neptune, Neptune's gravity can affect its orbit and swing it into an elliptical orbit. The problem is, Sedna never gets that close to Neptune. It doesn't get anywhere near close enough to be in that kind of orbit. And that means that something else is going on out there.
Sedna cannot be explained using objects that we know. Everything else, we can understand why it's where it is based on the 8 planets and many, many other small bodies. Sedna cannot be explained by that. And that was, that's the sign of a good mystery. Something else must have happened.
Looking at models for how you can change the orbits of objects, there's almost no way Sedna could have formed in our solar system and then had its orbit changed so that it's that elliptical and goes that far out from the sun. And that means maybe, it didn't form here. It may be an alien world.
How could our solar system have snagged an alien world? Long ago, it turns out, our sun may have rubbed cosmic shoulders with other stars. It was born in a stellar nursery, close to many other embryonic stars.
So the sun was born in a very dense neighborhood, whereby a lot of other stars were forming at the same time in the same region. It is absolutely possible that material could be exchanged between these stars as they're forming planets.
Sedna may have formed just like any other object around another star in a nice circular orbit out past the main planets of that alien solar system. But if that star got close enough to the sun, our gravity may have been able to lift Sedna out and steal it.
It's possible that other dwarf planets were abducted from other systems, and that these alien worlds carried alien water and even organic materials to the inner planets.
It's so tempting to think that we understand something as basic as our own solar system, our own home. When you discover something like Sedna, you realize there could be a lot out there that we haven't seen. There are objects that are small like Sedna that are just so far away that they are beyond our limit to detect them. So there could be hundreds, thousands, tens of thousands of objects out there, new parts of our solar system that are still waiting to be discovered.
Our understanding of the solar system is changing radically. Newly explored dwarf planets stun us, and even the most famous one, Pluto, reveals new secrets, making us ask, could these worlds be as active and alive as our own? Dwarf planets all over the solar system are revealing hidden lives. Salt on the surface of Sirius suggests liquid water beneath the surface. Farther out, the New Horizons mission found subsurface oceans on Pluto.
We used to think that water could only exist in this Goldilocks zone where it's not so hot that the water boils off and it's not so cold that it freezes. But that's not the case anymore. We look around and we find water in the most unexpected places in our own solar system.
It's kind of a revelation of modern planetary science that so many of these worlds in the outer solar system may have subsurface oceans of liquid water. It kind of boggles the mind to see how far we've come in our understanding of the interior structures of these worlds.
Finding liquid water so far from the sun stuns scientists. And the surprises keep on coming as we study these distant worlds up close. Makemake, 2/3 the size of Pluto, its surface is covered in ethane and methane ice. It reacts with sunlight, forming organic molecules called tholins, the building blocks of life. These color the planet red-brown. Farther out lies Eris. It is 9 billion miles from the sun, and its surface temperature is around 400 degrees Fahrenheit below zero.
Eris is an absolutely tantalizing object. We really don't know much about it at all. It should be very similar to Pluto. But one of the things we notice is that Pluto's surface is kind of patchy. There are areas that are very bright, but also areas that are quite dark. Eris, on the other hand, seems to be almost entirely bright.
It's one of the shiniest objects in the solar system, reflecting 90% of the light that hits it. Scientists wonder why. A clue comes from its near neighbor, Pluto. When New Horizons flew past, it spotted something strange.
One of the funny little details is that as we flew over Pluto, we realized that there were things that looked a lot like sand dunes down there. Now, that may not sound incredibly exotic. What's very interesting about a sand dune?
Sand dunes may sound dull, but they can reveal a lot about the mechanics of a planet.
Unlike the dunes we know and love on the Earth that are made of sand, the dunes on Pluto are made entirely of particles of ice.
There is only one thing that can build dunes: wind.
Dunes are like a visual representation of the wind that's moving across the valley and carrying the sands with it and depositing it into these big, beautiful dune plains.
Our planet is large enough to hold on to an atmosphere. Air warmed by the sun rises. Fresh air rushes in underneath, generating winds. Pluto is so small and so far from the sun, it shouldn't have an atmosphere, winds, or dunes.
The problem Pluto has, like other small bodies in the solar system, is that it's really hard for it to hold on to an atmosphere. It's just
And that'll be all for this episode. Catch next time where we'll be going over to help out the blacksmith and checking out the hyena den. So we'll be doing striking the Advil and Hideaway.
What are you talking about? What man?
The only man save you I have ever loved. No, don't look like that. There's no time. You have your duties. I am your mistress. Go to your queen.